Hey folks, today we're going to take a look at superpositioning with waves. Superpositioning is when you send a pulse down a particular wave and you have this wave coming back, in this particular case on a string, and the two pulses, their amplitudes, are going to add together with one another. So the positions are superimposed on one another, so it's superpositioning. In this particular example, you'll notice that I can generate a 1 centimeter amplitude wave, which goes down. And if you notice, it's going to be hitting this loose end. This loose end is not going to be having a greater density. It actually has a lower density associated with it. And so therefore, the wave is going to come back upright in the same particular position. And you'll notice there it goes, coming back upright. Now with this, what we're going to do is it's going to enable us to send two pulses at each other. So what I'm going to do is I'm going to send one pulse coming down, and then as soon as it goes and reflects back, I'm going to have this guy start. Okay, let's stop for a second. Notice we have a new pulse on the left and another pulse on the right. Those two particular pulses, as we take a look at them, we will notice that they are the same height. What do you think is going to happen when they pass each other? Let's take a look. So they're going to come up, and you notice these two parts, they start to lift as the two waves interact. As they interact, they're going to take the direction of each wave and add them together. And you'll notice, if that's the case, when they superimpose, it will basically be twice the height of the original. So now what you're noticing is, bam, it is a lot higher. That is called constructive interference. So if I go back to the original wave, and let's generate that original wave, and this time what I'm going to do is I'm going to generate another wave coming at it, but it's going to be half the size. So now, instead of the 1 centimeter and the 1 centimeter equaling 2 centimeters, think about what might happen. It's really actually simple. So the wave on the left, as you notice, is half, so that's 0.5 centimeters. The one on the right is 1 centimeter. Watch what happens when they pass. And do you think it's going to be higher than 2 centimeters or less than 2 centimeters when they add together? So here they come through. It's past that one, as each one is giving its own particular amplitude to it. Oh, and now we notice it starts coming back down. So what occurred in this particular situation is now it's about 1.5 centimeters. I know it's not exactly to scale, but it works out pretty darn well with that. And that's what we call constructive interference.